Hey everyone, we are back here in stage 3 for our next talk with Oliver. We're gonna talk about creating a distributed and reliable applications. Thank you, Oliver, for joining us. Welcome to the stage, and I hope everyone have a great time listening to you. I'm sure it's gonna be very interesting. I'll please everyone make your questions, and we're gonna have 25 minutes with Oliver, and then we're gonna review your question and ask him like everything that you want to know about this talk. So thank you very much. Thank you very much, Oliver. The stage is yours.
Thank you, Laureano. And hello, everyone. I'm Olivier Poupeney, Head of Developer Relations at Orkes. My talk today is about how to create distributed applications that can scale and can resist to all hurdles when the consumption becomes even more than what you could have ever imagined since you started the implementation. But first, let me start with a little quiz. Are you building distributed applications? It depends on what is your application architecture. So let's start by, is it with microservices? Is it with stateless functions? Containers that can be spawned and destroyed, or services that are talking together over RPC, like Google RPC? If your architecture uses an asynchronous communication like an event bus, such as Kafka or RabbitMQ. If you're in that kind of situation, so the answer is yes, you are building distributed applications. And it comes to think about what are the hurdles running those applications in such a distributed environment. First, and the biggest problem is that the network is unreliable. And your application has to manage that at some point if it is stopped because of a network issue right in the middle of the execution. You have also to manage all the dependencies that can have some kind of transient or permanent failures. The dependencies are also never stable. They change all the time. It's good we can use dependencies because we don't have to reinvent the wheel all the time, but we have to take into account when we use them that they are not stable at all. The system needs to manage their state of application flow. This is the fact that when you build an application that are consuming different services, and you need to handle timeouts, retries, rate limits also to make sure that if your application is provided to different kind of customers with like different contracts, that they can reach a certain limit at one point and then they cannot consume more. But also after those hurdles, you have all the challenges. How to recover when there is a problem, how to manage the application state, and how to handle distributed transactions and rollback when there is a problem in the middle of a transaction. It's very important in financial services, in healthcare, when there is a problem in the middle of a transaction that we can make sure we can roll back, especially if those transactions are also based on services provided by third parties. And last but not least, it has to scale. So you have to be ready for a large consumption, managing pipes between services, backups and retry, handle failures, retries and rate limits, handling back pressures when your services cannot really manage all the consumption, and have services that can auto-scale. After saying all of this, let's see a kind of example of what could be a distributed application, and let's go through this example. I took the example of a loan application, very simple. The loan receive the application from a user. We're gonna validate the identity of the user, score the risk of making that loan, validate all the collateral that comes with it, like the photocopy of the passport or things like that. If all succeeded, then we need to calculate what is the rate based on the amount that is requested, the duration, and send an approval notification. In this simple process, you can see that problems can occur everywhere. So you have point of failure basically every time you call one services, or when you rejoin services, if those services needs to be called and executed in parallel. So your application, if you need to manage that, can become really a spaghetti code if you need to code everything. But if I see a traditional architecture right now, and what could be wrong. So let's take an example of everything is developed as microservices. We are using PubSub mechanism for message passing, HTTP-based communication, and each service knows the next one in the chain to complete the transaction. So what can be wrong here? The first is the version coupling. When there is one version that needs to be changed, we need to make sure that all other services also are okay with this service, with this version. The deployment in lockstep mode, when you need to deploy multiple services at the same time. Or services that are responsible for dispatching calls to other services. A lot of things can happen here. The routing based on versions or message payload, when payloads change, and believe me, it changes pretty often, the message bus becomes a single point of failure as well. So you need to manage that part. And the application logic is distributed across many different services. According to a recent survey in this year by Deloitte, 70% of the time is spent on operations and maintenance compared to building the application. It's just too much. So it has a real impact on the total cost of ownership of the application. And here are the factors. The application flow changes all the time. It changes every time that the business needs to change, which is every single day. And the time to market is critical, meaning like those changes cannot wait for 6 months for their implementation. You need to change as soon as possible. Sometimes you need to prepare the change. If it is like a price change that needs to change from a year to another. So you prepare everything, and when comes the new year, everything should be deployed automatically. Some changes are just rewriting the flow and not necessarily the service itself. And also documenting the flow is really important, because in every project, developers move to different project or teams, or even they leave the company. They need to document the way the application is working so that the maintenance can be done. The support team needs to also understand how the internal logic of the application is made so that they can debug and find out why there is a problem somewhere. SRE teams needs to know how to scale up and down the service to not have infrastructure that are too much costly at one point for the consumption that is real. The management needs to know what are the uptime, make sure that the SLA is met for the services, and basically managing and handling this operational complexity is a big cost. So what if there was another approach than this traditional architecture? What if we could develop the application like we draw the workflow in a design tool? And this pattern actually is known as service orchestration. And this is what I'm going to explore right now with you with a tool called Conductor. Conductor is an open source project that has been built at Netflix by the founders of Orkes, and is still maintained by Orkes today. There is a very active community, so the product becomes more and more robust. And just believe, when you go to Netflix and you go to your homepage, all the content that you see comes from services that are orchestrated by Netflix Conductor. So you can imagine the amount of, when we talk about consumption, the amount of users that are behind at the same time consuming that service. It needs to be very, very scalable and reliable. So with Conductor, it has been designed to scale to an extreme volume, and it follows some design principles. No single point of failure, and all communications are made through persisted and distributed priority queues. This is really important. The orchestrator does the routing, no more the application. Services can be HTTP, can be gRPC, or simple code that can be developed in different many languages. I will explain that in the next slide. The services need to follow a single responsibility principle so that they are very stateless. So Conductor is a platform for building really distributed applications based on it's an event-driven architecture, and all communication are made through persisted, distributed, and priority queues, like the design principle. Services do not communicate directly. Conductor does the routing for them. All retries, rate limits, failures are handled by Conductor. And the application state is managed also by Conductor. Conductor has an API so that you can build your own monitoring tool if you want. You can trigger workflows from all the APIs that are available. Distributed apps with Conductor are really long-running workflows, and it can be you have, if you want, like 3 main entities. First, of course, is the workflow. It defines the application state, the routing and orchestration across different services. It becomes your distributed transactional backend for any kind of consumption. It can be from mobile apps, it can be for web apps, or even both at the same time. Workers are stateless components that can be developed in any kind of language. Conductor is really polyglot, so you can develop your workers in Java, Go, Python, C#, or whatever. It is really, you can do anything you want, and this can be executed from the flow. We're going to see an example in a minute. Those workers can run anywhere. So you can imagine a workflow where you have services that are on-prem and services that are in the cloud, in your private cloud, in a distributed, in an open public cloud. And you can make those workflows work seamlessly, really, with different kind of workers. So you can have a workflow with a worker code in Java as a one step, and the second step, it's something that is developed in Go. So it encourages also different teams to work together on the same project, different teams with different knowledge and they can use, of course, their preferred language. So the applications becomes really something that can use the API of Conductor to start, manage workflows, and Conductor will really manage the state of those applications for themselves. So let's build our own application in Conductor. So I'm going to pause right now on the slides. I'm going to go to the console of Conductor, and as you can see here, so I have my list of workflows, and I prepared for this session the loan application workflow. So I'm going to click on it, and we're going to see the workflow that is made with the validation of the entry for the loan application, Loan application comes with user information, the loan amount, the loan duration. So you see here the input parameters of the workflow. And then I'm going to do the identity validation. So call this service, call the risk scoring service, call the collateral validation service, and then send the email notification. So adding a new task is really very simple. I click on the little plus here, and I have access to all these different kind of tasks that I can do. It can be some operator, so I can do some switch, some loops. I have a fork here behind, but it can be also a dynamic fork with a unknown number of tasks that we want to execute at the same time. That's pretty interesting. So really, you can do simple to very complex workflows with the Conductor. When it comes to the execution, I'm going to run this workflow. So it's the loan application workflow. I put some default parameters, the loan duration, 12 months, 1,000 for the loan amount. I'm going to run the workflow. And here, as you can see, it has been already executed. So I can go to the execution. So what has been done during the execution of this workflow? I can see everything has been done properly. All the tasks, no failure, everything went well through the end. I can introspect also the timeline. What was the duration of each task? I can see like the validation of entry was 69 milliseconds. Then I can go and see for the 3 that was executed in parallel, and then the email notification. I can see here, there is a problem. The email notification has been sent before the 3 validation has been made. This shouldn't be the case. So for that, I'm going to go back to the definition. Again, I'm going to make a little change so you can see how easy it is to update a workflow and re-execute it. So I'm going to go to the rejoin of the fork, and I can see that this needs to be completed when it can be just 2 of the 3, but I'm going to say all 3 needs to be executed in order to continue and go to the send email notification. I'm going to save it and confirm the change. Go back to the run workflow. I'm going to run it again. So now I have a second one here that I can introspect. And if I go to the timeline, I can see that effectively the send email has been made when the rejoin has been completed. So all those 3 tasks has been completed. Of course, some developers will say, I don't like visual tools. I don't like no-code, low-code tools. I want to code. Everything that I showed you can be done just for POCs if you want, or just for documentation. And everything that you see is also a code. So based on if I go back to the definition, on this, the thing that you see, you can also go to the code and see that it's actually just a JSON definition. So I can either develop using JSON here directly, or I can automate the generation of that JSON that will be deployed automatically into Conductor, or I can use one of the language and the SDKs of Conductor in order to do all of this scenario by using all the APIs provided by Orkes. I'm gonna stop here, go back to the slide, and I think I am at the end of 20 minutes, so we can open for questions.
Hey, Olivier, very, very good presentation. Thank you very much. Very interesting. So everyone, if they want to ask any questions, you can ask in the chat. But I actually have a few questions that I want to ask you. I like a lot what you show. I'm very fan of low code, no code application, and I see that this project works a lot on the interface and a friendly interface. So you mentioned a bit about like how some developers are like they don't really like this kind of. How do you see the future in terms of like interface, and who are the users that you envision? We talked in one of our previous talks about the technical persona. No, it's like not like a buyer persona, but the technical persona that is going to use this kind of this tool that you're showing us.
So I'm going to give you my personal opinion. First, about low codes. Low code by a lot of different tools are described as a feature. It shouldn't be. Low code is a result. And this is exactly what Orkes is. It's a low code, it uses a low code approach because, yes, at the end, you're coding less than what you should with another architecture or another product or another platform. But it's not like a feature that let anyone develop applications. Conductor is a tool for developers. There is no, I don't see any business user that could use, because not only you need to, yes, it's easy to draw a line between two services, to change those services, but you need to know what means drawing a line between two services, the logic. If you don't understand a logic of an application, you cannot build a workflow.
Exactly. I see it as a time-saving tool, right? Like
exactly,
it will save a lot of time and scalability. No, like that's the whole point of the tool. And you talk a bit about one of the issues of the previous approach is the developers are changing constantly between companies, between areas and groups. Can you tell us a bit more about how this new approach help the company to maintain that logic in the code, that logic in the application?
Because the application in itself is now spread into this orchestration, opposed to having like a code in itself. And you know what is it when there is a team who leaves and a new team who take in charge of an existing application? They're going to say, oh, this is not the way to do. And there is also some good points about that is the fact that the application needs changes. So they say, oh, let's redo it, because it takes more time to go deeply into the existing code and understand the way it is done. And you cannot, sometimes they're going to feel that it's not written well. But the reason is also because all of the changes over time that has been implemented make the code a little bit less clean than it should be. And it's true that if you come like first day and something very clean on a blank page, it will be always easier and cleaner to implement something. So using the orchestrator instead of coding by hand in an application helps to avoid actually this rewriting, helps to avoid a technical debt that is growing over time.
Great, yeah, very interesting. And I think that we have time for one more question. For somebody that is starting to build their application, maybe thinking about doing an MVP, or would you recommend to start from the beginning with a tool like this? Because sometimes, you know, like when you build an MVP, you say, okay, I'll do it the way I know it, I do it faster. But I think for what you say, like, if you think about scalability, it's actually better to take a bit more time to implement something like this. Or like, what is your recommendation for somebody that's starting to do an application?
So at Orkes, we have a playground. So if you go to play.orkes.io, you'll be able to design your workflow and run that workflow without having to install anything. And for, I would say, out of the box, the scalability comes to your application. So there is no, you can even start by the open source that you can install on your own infrastructure And when it runs, you can migrate just by doing drag and drop into Orkes. It's as simple as that. It's plug and play.
Thank you very much.
I would say start really from the beginning by drawing the workflow and grow from the workflow your application.
Thank you, Olivier. Very, very interesting. So everyone, they have any more question for Olivier can contact him directly. And actually, I have a lot of notes, so probably I'm gonna contact you to ask you a few more stuff. And thank you very much for this. This is the end of the first part. Now we have let me check. We have we have the lunch break until from until 1:15, and then we're gonna join again to another talk in here in the stage number 3. Thank you very much, Olivier, and thank you to everyone listening.
Thank you, Loreno. Thank you, everyone.